This E2M Polytron case study comes from a large North American packaging line. Unbalanced lanes at a downstream packer are shutting down the packaging line. Plant engineers have tried multiple times to fix the code for the laner, but still can't resolve the problem. The question, is the laner the problem, or are more dramatic changes needed on the line? The video shows that the laner infeed lanes are unbalanced. The upstream cartners are cycling on and off, limiting the product flow downstream. However, the case packer is starved. It lacks the product in its infeed necessary to continue running normally. The unbalanced lanes consistently create about a 20% loss in throughput. Plant engineers think there are logic problems to the laner, but they can't figure them out, even after months of bringing in different teams to reprogram the controller. A team from E2M Polytron is called in. The new team works with engineers to develop several different scenarios to simulate and emulate variables and their effect on the line. There are 4 options developed. The first is to take one more crack at the laner code. The team creates a PolySim emulation, a scaled visual representation of the line, which is used to test and debug the code in the line's programmable logic controller, or PLC. PolySim models the working packaging line in a real-time environment and sends a series of variables back and forth to the PLC. After the team makes changes using the emulation, only negligible improvements are observed. The team starts to think logic changes may be needed further up the line. A PolySim emulation allows the team to create changes to the 3-dimensional scaled visual of the line, whether it's package dimensions, sensor locations, or line layout. Among the options tried was adding buffer after the laner. However, there was nothing to fill up. The system was already starving the case packer, so adding a buffer would provide no benefit. Another option considered was changing slug lengths. Slug lengths are controlled by the PLC, so again, logic changes were made and tested on the emulation. While the team realized some benefit after making all of these changes, it wasn't enough to balance line operations. One option remained, adding buffer before the laner. The photo eye is getting tripped, shutting down the upstream cartner. Due to the line layout, the sensor could not be moved or other material handling problems would occur. But what if the PolySim model could emulate moving the photo eye upstream? Moving the photo eye would mimic adding buffer before the laner. And because PolySim can emulate the effect of product design variables on the working line, system changes can be created and tested without impacting the actual system. This provided significant improvements to the line. When a product backup occurs, as long as the cartners are not shut down prematurely, the laner will process all of the packages, keeping the case packer in normal operation. The lanes are now balanced. The improvements also lead to a 16% jump in average throughput of the laner. Confirming that additional buffer would smooth out operations of the line, the team now had a solution to implement. Again, physical limitations of the existing layout would require significant funding and time to allow the additional buffer. But the team now had a sound justification for the project and could write it up with confidence.